All right, let's continue talking about the application of differentiation. I'm going to turn to concavity and a second derivative test. Concavity refer to concaving upward and concaving downward. So this is a typical case of concaving upward, concaving downward. And we talk about first derivative test, and in this particular section we're going to focus on second derivative test. And it's used to test the extremer. Okay, we will learn how to determine intervals on which a function is concave upward or concave downward. We'll learn how to find any points of infraction of the graph of a function, apply the second derivative test to find relative extremers of a function. Concavity, again, as I mentioned, two types of concavity: concave upward, concave downward. Definition of concavity: let f be a differentiable function on an open interval I. The graph of f is concave upward if f prime is increasing on the interval. Same thing as saying slope of tangent line is increasing. And a concave downward on interval I if f prime is decreasing on the interval, meaning slope of tangent line is decreasing. Let's take a look at how we interpret this, right? Let me show you. This is concave upward. Typical case of concave upward. As you can see, if you draw the tangent line, you start with a very small negative number, then keep getting bigger until we reach 0, right? Have a horizontal tangent here which slope is 0. Then when you move upward, you see that slope become positive, and then it becomes bigger and bigger because the line becomes more steep. Okay, so going from negative, very small negative number, to 0, and gradually move up to very big positive number. So this is increasing, so slope of tangent line is increasing. And for the concave downward case, it's exactly opposite. So meaning you get a graph like this. Then if you look at the slope of tangent line, she's just getting bigger. Start with a positive value, right? Then becomes smaller and smaller, and at the extrema here it becomes 0 with the horizontal tangent. Then it's just getting smaller and smaller. Negative, very negative. Start with positive, very positive, big positive number, to 0 until negative, right? So that's why the slope of tangent line is decreasing here for the concaving downward case. And let's look at concavity in a more deep manner. So the following graphical interpretation of concavity is useful. Let f be differentiable on an open interval I. If the graph of f is concave upward on interval I, then the graph of f lies above all of its tangent lines on I. Also, you see all these tangent lines are below the curve itself. Okay, if you look at the value, right, start with the negative value, it becomes positive, becomes bigger positive values. So slope tangent line is increasing in this case. Secondly, let f be differentiable on an open interval I if the graph of f is concave downward on interval I, then the graph of f lies below all of its tangent line on I. So all these tangent line is on top of the curve itself. As you can see, this is positive value because negative become smaller negative value. So you see the slope tangent line is decreasing. They're pretty consistent too. The observation is consistent with the trend of the slope. Okay, so let's take a look at the test for concavity. That be a function whose second derivative exists on the open interval I if the second derivative of function f of x is greater than 0. For all x in I, then the graph of f concave upward on I. Secondly, if f double prime of x is less than 0, meaning second derivative of x. Same thing as slope of it, not a slope anymore. So this is like the second derivative of f of x is less than 0 for all x in I. And the graph of f is concaving downward. So second derivative is key thing. Second derivative is needed for test of concavity. Concavity. All right, let's look at example. See how we determine the concavity. Determine the open intervals on which the graph of f of x equals to 6 over x squared plus 3 is concave upward or downward. If you look at the function, since x squared plus 3 is always greater or equal than 3, so the denominator is never going to be 0. So the domain here, domain of function f of x is going to be from negative infinity to positive infinity. This is very important when we carry out a problem later. But first of all, we need to find out the second derivative in order to test the concavity. So first of all, we got to find the first derivative in order to find the second derivative. And here we're going to use the quotient rule. So numerator is f, denominator is g. When f equals 6, f prime, the derivative of constant is 0, right? G equals to x squared plus 3, and g prime is going to be 2x plus 0, which is just 2x. Now we can apply the quotient rule. The quotient rule, prime g minus fg prime over g squared. So f prime of x equals f prime, which is 0 times g. G is x squared plus 3 minus f, which is 6 times g prime 2x over g squared, so it's x squared plus 3 times c squared. If you simplify this, 0 times anything is 0, so you get negative 12x over x squared plus 3 squared. Okay, that's going to be the first derivative. So again, we're going to apply the quotient rule one more time. F now is negative 12x. F prime is negative 12. G is x squared plus 3 squared. And G prime, we're going to apply the chain rule here. First of all, you apply the power rule. X squared plus 3 reduce the power by 1. And we differentiate inner function. So the inner function is going to be derivative of x squared is 2x. Derivative of 3 is 0. Okay, so we get a 2 times 2x times x squared plus 3. So we get a 4x times x squared plus 3. Okay. Alright, so now we're gonna apply the quotient rule one more time. F double prime of x equals to f prime, which is negative 12 times g x squared plus 3 squared minus f, which is negative 12x times g prime. G prime is 4x times x squared plus 3 over, and g squared is x squared plus 3 square. Okay, so now we gotta simplify this. So we get negative 12 x squared plus 3 square minus plus, right? Minus become plus 48x squared plus 3. Bottom is x squared plus 3 to the 4th. Okay, then we're gonna reduce every single term on top and bottom by x squared plus 3. So now we get negative 12 x squared plus 3 plus 48x squared over x squared plus 3 cube. Then we distribute it, combine like terms, we get negative 12x squared minus 36 plus 48x squared over x squared plus 3 to the 3rd. Then it becomes 36x squared minus 36 over x squared plus 3 cubed to the 3rd. So that's the second derivative. Then next we're going to figure out the numbers we're going to test for concavity. So we're setting f double prime of x equals 0. That means 36x squared minus 36 over x squared plus 3 to the 3rd, 0. Use cross multiplication, we end up with 36x squared minus 36 equals 0. Then we solve for x. Factor out 36 x squared minus 1 equals 0. Setting x squared minus 1 equals 0, then x equals plus minus 1. Okay, so now we find out the possible values to test for concavity. Once you have that, then we can start create a table and then start testing, right? So we're gonna create a table. So start with test interval. From x infinity to the x value is plus minus 1. So that those two values are going to separate the domain into 3 pieces. 1 to 1, 1 to positive infinity. I'm going to pick test value within each interval. So here we can pick -2, 0, 2. Then we start determining sign of f double prime of x. So f double prime of -2. So f double prime of x equals 36x squared minus 36 over x squared plus 3 to the third. If you look at the equation, the denominator is always going to be positive. So we have 36 times -2 squared minus 36 on top over -2 squared plus 3 to the third. On top we have 144 minus 36 over, and denominator is 7 cubed. 144 minus 36 is 8 over 7 cubed. This is definitely greater than 0, so it's positive. You don't need to figure out the answer. All you need to do is determine the sign. Once you know the sign, then you're ready to go. So the conclusion for this case, this is concave upward. And second one, second interval, at the f double prime of 0, so it becomes 36 times 0 minus 36 over 0 squared plus 3 to the third, so it becomes -36 over 3 cubed. This is definitely less than 0, so it's negative. Negative indicates concave downward. The third interval, 2f double prime of 2 equals 36 times 2 squared minus 36. And 2 squared plus 3 to the third. This becomes 144 minus 36 over 7 cubed. 1/7 cubed. Again, it's greater than 0, so it's positive. That means it's concave upward.
Recording something? Oh, sorry. You have a
Recording video. It's okay. No worry.
Do you have a headphones? Like maybe the ones that using a USB or headphones? Any headphones?
I don't think I have one, Eugene.
No.
Yeah.
Let me ask you.
Maybe. Do you want this one? This is
No, I need
No,
something.
oh,
I have
for the
the-
phone, for cell phone.
Yeah, something
Okay.
for the computer, but something that I can just
I see.
hear while people are around. Okay, thank you.
No problem.
Okay, so that's pretty much it. So we figured out the concavity for each interval, and the table is the best way to perform the test for concavity. As you can see, this table is a summary of what we just did, and the result actually is consistent with our analysis. So as you can see, from -infinity to -1, this is concaving upward. Okay. Okay, and then from -1 to 1, it's concaving downward. And then from concaving upward to concaving downward, this is the infraction point, right? We're gonna get to that in a second, but that's what happened here. And from 1 to positive infinity, again, it's concaving upward. That's at this point. This is another point of infraction. We're gonna get to that concept in a second, but the graph actually is consistent with our analysis. And now let's take a look at the point of infractions. Point of infraction is where concavity changes. Concavity changes. Meaning change from concaving upward to downward, or concave downward to upward. If the tangent line to the graph exists at such a point where the concavity changes, so this keyword, concavity changes, that point is a point of infraction. Three types of points of infraction are shown in below. So start with the concaving upward to concaving downward. So we get a point of infraction here. Second case, start with the concaving downward to concaving upward. That's a point of infraction here. Third case, concaving upward, concaving downward, point of infraction in the middle. So three different cases where the concavity changes. And at that point, that's a point of infraction. Let's take a look at the definition of a point of infraction. That f be a function that is continuous on an open interval, and that c be a point in the interval. If the graph of f has a tangent line at this point, c comma f of c, then this point is a point of infraction of the graph of f if the concavity of f changes from upward to downward or downward to upward at a point. Point of infraction theorem about the point of infraction. If c comma f of c is a point of infraction of the graph of f, then either f double prime of c equals 0, or f double prime second derivative does not exist at x equals c, meaning it's undefined. Example 3, finding points of infraction. Determine the point of infraction and discuss the concavity of the graph of f of x equals x to the fourth minus 4x cubed. So in order to figure out the point of infraction, we have to find the second derivative. So in order to find the second derivative, we gotta find the first derivative. So the first derivative, we apply the power rule. So 4 times x, 4 minus 1, minus 4 times 3 times x, 3 minus 1. So end up with 4x cubed minus 12x squared. After finding the first derivative, the second derivative, you apply the power rule one more time. So 4 times 3 times x, 3 minus 1, minus 12 times x, 2 minus 1, times 2 minus 1. Remember to put the exponents in front. So 2 goes in front, x, 2 minus 1. So end up with 12x squared minus 24x. And now we set the second derivative equal 0 and solve for x. So set f double prime of x equals 0. That means 12x squared minus 24x equals 0. Then if you factor out 12x, then we get x minus 2 equals 0. If say each one of them, each factor equals 0, we get x equals 0, x minus 2 equals 0. X equals 2. 0 and 2 are the points we have to check, right? So now let's create a table. So the test interval first one, let's start with the domain of f of x. Since it's the 4th degree polynomial function, so the domain is all real numbers. It's from negative infinity to positive infinity. So the first interval is 0, 2 will separate the whole domain into 3 sub-intervals. So first one is from negative infinity to 0, and 0 to 2, and from 2 to positive infinity. I'm going to pick a value from each interval. First interval we can pick negative 1, second interval 1, third interval we pick 3. Then we determine sign of f double prime of x. So f double prime of x for negative 1. So you get a 12 times negative 1 squared minus 24 times negative 1. It becomes 12 plus 24, which is 36. This is definitely positive, greater than 0, so positive. Positive tells us it's concaving upward. The second interval, the test value is 1.
有没有想你今天在这边？
对，我有时候都会跑过来，跑过来做点那个，
做点作业。
对，
没有作业，走，没事。
应该都不来。
怎么样？你拿书啊？
对，拿个书。然后今天刚好有个什么 orientation， 我就想嘛去参加一下，以前都没去。
去一下有用。
对。
你比如说，你如果用 website 什么，你可以学一点。
哦，那个是 workshop， 昨天去的，然后今天是那个 orientation， 可能他又会讲一些什么，有什么 benefit 啊，还有一些什么blackboard 怎么用啊，七七八八的这些吧。对，所以今天就不太。
没事，你如果 blackboard 不会用，你过来问我，我教你。
下个学期教这个。
150啊。
对，可能要是来教你，就是那些要一些资料吧，比如说 midterm 啊，大概是怎么样子才心里才有底。
行，我给你看，没关系，你过来找我，我周三一般都在这里。
周三对吧？
周三2点4点就系会，你一般也在这吧？
周三我这个学期没课，就周二跟周五的课，但是我觉得应该周三、周四我
周一来嘛，
进来。
周一我也会在这里。
周一、周三都在对吧？
对，周一、周三都会在，我可能会在 office hour， 我可能会在。对。
反正到时候微信问你什么时候在。
没事。对，
我就想看一下，可能这本还要回去备个课什么之类的。
对，要备课，对。
对。
这个
统计。
对，这个好有意思。
很有意思。
但学生很弱，
学生太弱了，没意思。对，我就很想教这门课，因为我觉得我教的时候我会给，就等于重新再学一遍，学得更深一点。
对，
你更去，你有时候你去知道怎么做题的时候，你学的时候没有去很深入了解，有时候真去回想一下，哎，好像都不知道怎么解释。所以我觉得特别想教这一门课。刚刚好他今天又换了一门课，本来
是041是不是？
对，本来是那个5-1给我2门课。然后有一门课，那几个 section 可能就几个学，然后 cancel 掉了。然后他就说，哎，你要不要100？我说有没有150啊？他说有啊。我说那给我150吧。
是他是吗
？Steven 对，他还在吗？今天应该不在了吧？现在？
在，我看到他了。
现在还在哦。
现在不知道，早上来的时候他在。
对。
他很忙，现在要一直删这些。
对，然后刚好进来的时候。
我给你看，我在做这个。
做什么？
这是个 video， 我用这个，这是 PowerPoint。
哦，用 PowerPoint 解题是吗？
这个是可以自己在上面写的，很有意思。
是我们这边，哎，它是新开发的一个课程还是什么？
这是我自己，我要开发一个 hybrid 的
课是吧？它是录下来的是吧？
这我自己录的。
你自己录是吧？因为我知道是那个，我以前上课的时候，老师用的是他有个那个，老师是直接在下面写的，他不用再把书，他用电脑写，他想换颜色，各种颜色都可以。
对，但我这个是可以直接弄成那种 YouTube video。
哦 ，YouTube video
直接 po 上去。
哦，那很好。
学生可以 review。
是这个 app 吗？还是说什么？
这个 app 要钱的，是 app。
哦，是 app。
要 PowerPoint 跟 app 结合在一起。
跟在一起。
找我。
嗯。
What's up? Hey. How you doing?
How's everything?
You have the mustache.
So who got the job?
Who got the
The
job?
CLT job. You?
Ning, no, not
Oh,
me.
Ning?
Yeah, Ning.
He's a good competitor though. Yeah, but
Why they give you?
Huh?
Why they don't give it to you?
I don't know.
sometimes it's luck, you know.
No, no,
Yeah.
I'm going to my office.
Okay, so what time you leaving? I was just here for a few minutes. She would show me something.
哇，那这个很好，这是学校拨给你的还是什么？
不是，
Yeah, the
是你
hard
自
stuff
己
is
弄
3:45 anyway, so.
Yeah.
我看到他们有个 program 可以送这个给你自己研究的那个，就是晶晶他们在弄的一个什么课
What else
程，
are you
开发一
teaching
个新
besides
课
stats
程。
this semester?
上次我
Yeah,
看
I'm
到
teaching
他
two
们，
classes.
我这就是新课程。
哦，
Okay.
你也是那个一个，
我应该不是，
哦，你应该不，
我就是自
Are
己
you
有
using
兴
this
趣
for
自己
both
弄。
sections or just
Yeah,
one
for
section?
both.
Alright, cool.
挺不错的。我就想
他们
说
想教这个，所以我就弄了一个这个。
这个是也是 determined by point。哦，这个是什么 206啊？什么
301啊
301
calculus
？calculus 可以这么弄，那也挺
可以
不错的。
可以。
什么都可以。
其实 calculus 是这样的也 OK， 应该学得懂，就可以。
你认真去学的话，都可以学得懂。
对，
对，挺好的。
对，
也是 online 课程吗？
不是
不是
hybrid。
How did you like using Connect for
Just
Math
可能
104
他可能
last
现在慢慢
semester?
过
It
渡
was
吧，
okay, but in the
将来的
beginning, this
将来的
is
世界就这样，
都
所
是
以都是
电脑
online 的，
对
知道吗
online
About what?
学生不需要来学校。
可以省很多。
我觉得再过20年的话，可能
They do their homework.
以后我们的趋势就这样，在家里工作，
And
对，
直接跟
老师都可以
I
在家
don't
里
see
工作。
my
对
grade.
就
What
可以
is
work
my
from home
grade?
而且这样子很省精力，你知道吗？因为你做一遍，你就不用像你不用教2堂课，你要去重复这些东西。
What happened?
但也有 face to face 也有 face to face 的好处。
So if
有
you
一些
do
学
homework
生
with the
看学
app,
生
you're
学习的
gonna
类
see
型是
the
蛮，
grade.
有一些学生是学习这种
But
难
if
为
you
有
do
的，
it
你必须要给他
using
看
my
完的，有一些
homework
就是啊，
system
你必须要
that
讲给我
aside
听，或者
and
怎么
they
样
will
子
see
的。
the grade.
当然
Because
face to
when
face 也
you do
有
the
好处，
apps,
就是
the app just let you do the
你可以
practice.
及时的根据调整自己，你可以根据学生的反应来调整自己。
So
对
when
对
I
对，还
figured
有
it
时候
out, that's when I told
对对，
them,
比如说学生
if
有一
you
些
go
出
by
错
the
了，你就可以
apps,
point
you
out
will
出来
not
对
see
对对
anything.
这些东西。
这个
我觉得可能这个
嘿，
这个
You had a message in your box. Did you check it out? A paper message.
leave a message
A message. A paper
in your
message
mailbox. In
Yeah,
your
of
mailbox.
in your mailbox from a student. She came last week, I think it was.
Yeah. She wanna beat me up.
对，我觉得可能老师这个20年都不一定能不能 in person 这个 face to face 应该不会改变的，但是趋势会降低吧，会降低。
对对，会降低，会越来越少，
对，
因为毕竟这个趋势，学校一直
什么都是
push
电脑
大家做这个。
都不是
对，很早以前就 push，几年前嘛，我开始最早做那个150的时候就
最近有
我就一直
这些
push，没有一直都在 push， 只不过很少人愿意做这个。
耗时间。你看我051我在打那个
我，一整个 winter 在做这个，
你
一直在做这个。
打是吧？
对，要
我上
做很
个学期不
多东西。其实
是只上一门课嘛，但是我把我所有的资料都拿去打成就是打成 Word 文档的那个。虽然说只是051，但是我打了很多东西。
哦，对，那个
也是在一直
好累
调整，一直在调整。对，我就想把它弄成 e-file 模式。
我教了150这么久，我每个学期都在改东西。
都在改，但是你是手写版的吧？还是也是打印的？
对，
第一个学期有没有打很多？
第一个学期最早备课的备了很多，
对吧？
然后后来要根据慢慢的调整一些，
慢慢
有些东西要删掉，有些加进去。
对，还有根据他们学校的系里面，
还有他们 syllabus 也会变。
对。然后那个新科也是，他说：“哎，你什么时候可以用？”我说：“我还在调整，没办法，因为都是乱七八糟的这些，估计就我看了的学生不可能去看了，给你也没用。先等我调整完再说。”
他跟你要？
对，他跟我要。我说
：“他为什么跟你要？他教了这个很久了。”
他教会了很久，他讲他不是弄了一个 website 吗？他想把这些放到他的 website 那边去。
Then the
他自己肯定不会去打，很少人会去打。
specifically for math, so you used
太
Alex
简单
during
了
the summer，
而
break
且又没有
program,
online 的
right?
课，
So
唯
this
一
is
不可能
connect
有 online 的课。
integrated with
他
Alex.
自己不
有啊，
So
有
that's
啊，
the-
有啊。
唯一都有 online 的，我的妈呀！
It more looks like
都有
connect, but the questions
我知道
are
谁教 online 的，5一教了很久了。
很久了，对吧？哦，
Can you
怪不
open
得
up
我
your
知道
email so
人
you
家
could
不
look
知
at
道
the
我
login
知道
name? It's J Conti.
有
对，
008都有，012都有，056也有，
这些学生觉得效率高吗？
要看你老师花多少心思了。
没有，老师花多少心思，以为学生自己能花多
So
少
you
心
got
思
an
也是没有。
email. Where's your
是双向，
对，双
双向选择
对
是。有些学生就会选特定的老师，他们你可能达到的学生都是一种类型的学生，
哦，
And then this
对
one?，
也有这种。
大部
如果教
分是
久的话，
有一些老师
I'll just
是
search for it.
然后
他
呢有口碑，外面人家会传这个老师教怎么样，怎么教的，这个考试怎样，他就会有特定的学
对对，
生
就有特
会专
定学生，
门选你，
就是我只想考试的那些学生，
对
然后
对对
他就会选这种类
他
型。
只想拿 A
You
的
still
学生
use
就知
these
道选
uh,
谁。
VH?
你的那个 teaching style，他会决定你考什
Some
么
of
样
them
的，
is, I don't know who's doing it.
There's VCR still?
还是挺
Yeah, because they have some.
Not anymore, not anymore. They,
I was
they
gonna
get
say,
rid of
this
all those VCR videos.
Oh my goodness. Very
Pretty old
old school.
fashioned, yeah, pretty old
我问你，
fashioned.
现在有一个老师，我当时也问了黄老师，我说那个老师在做什么？他说教051嘛，他发 email 说什么要让学生考试，他可能在收集数据，要分析吧，一个老师。
我加入那个了
你加入那
，Clever
个？
Ladders，
It's not this. No, it's not this.
Clever Ladders 嘛
Go to the search
他的
tab here.
Kathleen 又分号里
Let's type it.
我也
我记得
收到了
那个苏珊那个
，Winkle 也在，他也是，他也是其中
哦，你
一个。
加入那个，就是你愿意给他考是吧？
对，给他考。
Here's your
无所谓
login.
是要 in class 考还是什么？
In class 当然要 in class，
就是还
You
要
need
开
to
20
set
分钟
set your.
一个。
看看题目看一下，我
What do
也
you
不知
want
道
your
什么
password
题
to
目，
be?
他没放我 mailbox。
哦，就说你是说你
周四、
在
周五才放我 mailbox。
哦，题目看一下，如果不喜欢的话就不给考，随时可以退出，对吧？
对，It's not an application，不是 application，是
我知道
volunteer。
只是帮他做事情而已，只是在帮他做事情而已，帮他那个。对，我到时候还没回答，我就想说到时候问一下大家的到底
我上去教这个课，好烂啊！
这个
我要哭了，我要教哭了，真的，
学生很烂是吧？
好
J
烂，好烂。
Do you want to write that down
是那
somewhere?
种 CD 的学生，超级烂，非常非常烂。
什么
不一
都会吗
定不一定，就是本来就是这门课哈，本来还可以的，因为最早教的时候还可以，但是我觉得学生现在越来越次，或者是因为我那课刚好 CD 的课，可能 CD 的学生很烂，
一个学生很烂，
When we go to collect math, that's
教的
why.
好辛苦。
我
Yeah,
就
so I'm
做
gonna
好
put
准
Connect
备。
Math. I'm gonna put it in your favorites bar.
对，第一个学期会很煎熬，特别是
然后还一边备课，很多东西都还没调整，可能学生有点不大接受，怎么样都还没有经验。
需要那个。
Mr. Zhang,
学生很烂，是以前几
how
个
you
学期
doing?
Summer 的时候比较好
，summer
Trying to be slick, Miss Rosa.
，Summer 的时候比较好一点。
哎，那这种你2、3他们作业是直接从书本上，还是你自己出题目？
我用一
J Conti 58.
我用 Math Excel，我直接我有一个 online 的 course，不是我有一个这个，不过你可以不用，因为这个要钱的，
哦，你自己买的是吗？
不是我买的，学生要买，
学生？
但它有跟书60块钱，
Have you ever
你用
used
这个是这本
Touchdown
书吗
before?
嗯，
My
一样的都是这
Touchdown
本
is
书
an easy
My
way to
stand-up.
create tests.
这里面没有 code 吧？
So I'll
我
show
用
you
的
how
是
to do
因
that
为我
too
最
if
早
you have
做的
time.
时候很早以前，原来是 Math Excel，现在
Are
改
you
成这
tired
个，
of
不
dealing
过
with
是一个
student
公司的，
cases for
哦
他们
incomplete
东西都一
homework?
样。
The late
一样
submission
吧
feature allows students to continue working on
你
assignments
可以用
after
这
the
个
initial
Stats
deadline,
Lab 更好，
but
更
with an
新的。
optional
没有
penalty
你
for
题目，
determined by
因
you.
为我
So
当时
this way
学
you
中
don't have
文
to
那
keep
个时
extending
候，
deadlines.
老
You
师
can just
根本
tell
没有什么，
students,
直接是
you know, if you
上
don't
学
get
的
it
题
handed
目
in time, no
去做
problem.
就
You'll
好。
just get 5%
对，
deducted
你可以
every
这
day,
样，你
or
第一个
10%
学期先这
deducted
样，
every day, whatever it
第一
might
个
be.
学
So
期
you
这
can
样
set that. This way
对，
you
你
don't
慢慢以
have
后
to.
再，
This way
你
you tell
现在
students no
去
excuses.
弄
对啊，
You
你
来
现
can't
在
不
你
及
跟我
了。
讲，可能
That's
我都不
fine.
大
But
清
just
楚
know
是
there's
什么
5%
意思。
every day.
就是 My Stats Lab，
Whatever you want.
其实是
We can set
Pearson
that up.
Company，都是一个公司的。Pearson，
Okay, so
对，我就
这是很大的
正常，
publisher，
我知道，我们几乎好多书都是
对，
他的。
都是他们的。
对，我就
this is
差不多就是
math
definition
150.
讲一下，就是按正常的
what's the first
definition
section
怎么做题，sample 讲一下，让他们去做题目。
1700
第一个学期可能不会有太多的那个，我要教一
要
两个。
多做题，我教的时候还用 Excel，不过他们好烂，
不一样，他们不会，有些人电脑都开不清楚，
也有不厉害的少就行。
厉害的少不多，但是
教的好辛苦。
不要吓我，我自动要求的，因为我就想教一下统计。
没事，说不定你也有可能你遇到学生好，
Yeah, I think it's a step-by-step
你
approach.
反倒
Yeah.
教的不久那好，你拿到全是 random 的学生，可能有好的有不好的混在一起。
This one.
我教久的呢
The statistic they use is not this Blumen.
Emails, it'll give you all the information that you need now that I know what you need. But for now,
顺便去
just
改
keep
一
building
下
your course under this one,
我觉得
and
这
then
个可能
we'll
就
make it
做
work
几
for
个
the
小
other
时
one
我
too.
都这样子。
Alrighty.
现在已经不是这
Have a
个
You too, thanks.
行行行，
Bye.
Bye.
拜。
Bye. Take care.
So you're piloting Bruma's textbook?
Yeah.
They have online homework system?
Yeah.
Oh, that's good, that's good, that's pretty good. Yeah.
What I try to do, man, is try to make the students save some money.
Oh yeah.
Because as soon as we
It's
can
free
make-
for students?
Yeah, it's free. Because as
They pay for it.
we don't pay nothing.
I don't pay nothing.
The student don't pay nothing. So even the textbook, the
But
ebook.
how
they
about
don't pay.
after trial? They still after pilot?
After
Do they
that?
have to pay?
Nah, still
No?
depend. If I would not have the same student.
I see.
But in a while, they might ask them to pay, but it will
Okay.
not be too much.
Okay, I see.
So
$20,
that's why-
$30, that's
yeah,
good.
Yeah, that's why I emailed the
More than
chairperson.
$100,
Yeah.
then that's too much.
I said to the chairperson, it is possible that I can pilot them because last semester they have to pay the book for $145.
Yeah, of course, of course. It's very
So
expensive.
some of them, man, they cannot even afford it.
Yeah. yeah.
So what I
Right.
did, I have a couple code at Boom when I was working at York College. They gave me for free.
Okay.
I have to give it in a class, give it to the student. Yeah. So when I give it, to the student, are you serious?
Mm-hmm.
You don't want money for them? I said, no, I give it for free. You take it. But only one thing, you have to do good in my class. Otherwise, you will pay me for it. Yeah, but this one, since she emailed me, she said, do you want to pilot this one? I said, it's fine, because this semester I don't need to pay for 56.
Mhm.
Code for 56, I don't need to pay for my 2,000.
Wow, 056, that's very expensive
Yeah, I will
too.
use the web work.
Work. Oh, yeah, work. Good,
Yeah,
good,
I
good,
will
good
use the
stuff.
free work for
Yeah, yeah,
today.
it's good.
Yeah.
all right.
all right. No, I don't check yet. I'm going to do that right now. After that, I'm leaving. Where is my key? Anyway. Yeah, I'm figuring it out.